Let's recap on what we learned in carbon compounds in the last two videos. The first thing we learned that carbon has got 4 valence electrons. Hence, every time we write a carbon atom, we attach these 4 arms. These 4 bonds are available for bonding with 4 other atoms. Then we learned about the alkanes. And the alkanes were hydrocarbons with a general formula CnH2n plus 2. The first alkane we learned was methane with 1 carbon, so C1H4. Then we learned ethane having 2 carbons, hence the formula 2n plus 2, and that becomes C2H6. And then we learned propane having 3 carbons, and the formula is 2n, n is 3 plus 2, and that would be C3H8. We also learned that alkanes have single bond. The bond between 2 carbons is always single. So this was an alkane with just a single bond in between. Then the next we learned about alkenes, and these alkenes had double bond, and the general formula was CnH2n. The alkene started with ethene, not with 1 carbon. It started straight off with 2 carbons, means C2H2n, 2 into 2, that is C2H4, and we called it ethene. Then the next with 3 carbons, that is C3H2 into 3, that is C3H6, and that was propene. Then we also started with 4 carbon, that is C4H2 into 4, which is C4H8, and we call that butene. Now in these alkenes, at least 1 bond between 2 carbons is double. There may be many of them are single bonds, but at least 1 bond is a double bond. Today we are going to learn a new compound, and those are alkynes. And in alkynes, at least 1 bond between 2 carbons is triple. And the general formula is CnH2n minus 2, and they have triple bonds. So here's the chart on alkenes. The ending is YNE. They have triple bonds. General formula CnH2n minus 2. The first member of the alkene has 2 carbon. So we have carbon here and 2 with this 1, 2, 3 bonds. It should have a triple bond for an alkene. Now let us see how many more hydrogens can this carbon accommodate. So here we have this carbon with 1, 2, 3, and the other one 4. So I will put a hydrogen here. It can accommodate only 1 hydrogen. Now let's get up and see the next carbon. It is already bonded 1, 2, 3. How many available? 4. Only 1 more. So this will be 1 hydrogen. So this is the first alkene, and the molecular formula you can see is C2H2. So that we write it here C2H2, and it is 2 carbon. 2 carbon means eth, and YNE means it is 2 carbon with a triple bond, so ethyne. Next one, a second member, 3 carbon. So we have 1, 2, 3 carbon, and because it is triple bond, at least 1 bond between 2 carbons should have a triple bond. So let's see how many hydrogens can this first one accommodate. So we have the carbon here, 1, 2, 3, 4. For the second carbon, we have 1, 2, 3 and 4. It cannot accommodate any more hydrogen. All its 4 bonds are occupied. Now let's go ahead and see the third one. How many more hydrogen can it accommodate? There's one bond here, 1, 3, 1, 2, 3, 4. So it can accommodate hydrogen, hydrogen and hydrogen. So to write the structure of this, now you will have here CH first carbon, the second carbon, and the third carbon has got 3, CH3. So the formula C3H2n minus 2. So that is 4. And since it's 3, it is a 3 carbon, it will be propyne, YNE. Prop means 3 carbon, YNE, propyne, 3 carbon with triple bond. Now for the third member will have 4 carbons. So let's write 4 carbons, 1, 2, 3, 4 carbons. And remember, between 2 carbons there should be a triple bond. To start with, we'll put the triple bond always between the first 2 carbons. It could go even here, it could go even here, but for convenience now we will just put it in the between the first 2 carbons. So now let us see the first carbon. How many more can it accommodate? 1, 2, 3, 4, 1 hydrogen. Now for the second carbon, we have 1, 2, 3, 4, all occupied. There is no place for more hydrogen. For the third, so you have 1, 2 already attached, 3, 4. There are 2 more hydrogens that it can attach to 2 more hydrogens. And for the last carbon, 1 already attached. How many more available? 1, 2, 3, 4. So hydrogen, hydrogen and hydrogen. So this would be the structural formula of an alkene with 4 carbons. So if we were to write it, we see the first carbon is attached with 1 hydrogen, second no attachment, third is H2 and the fourth is CH3. The formula will be C4 and the H will be 6. Since it is 4, it will be called butene, YNE, because it has got a triple bond. Now for the fourth member, we'll have 5 carbons. Now you go ahead and try to draw the structure on your own. Pause the video and try to draw the structure on your own. So first you'll draw your 5 carbons, then you have to put a triple bond. So I put a triple bond here. And now if you guess, this hydrogen can accommodate only, this carbon can accommodate only 1 hydrogen. The second carbon cannot accommodate any more. It is all full with 4 bonds. The third one, this third one will accommodate this 1, 2, 1. It can accommodate only 2. The fourth also can accommodate only 2. And the last one will accommodate another 3. So this is your structure of 4 carbons. And this is 5 carbons, not 4 carbons. And the general formula will be C5. Let's put this 5 here. H2n minus 2. So that will be H2n will be 10 minus 2 and that will be 8. Since it has got 5 carbons, it will be pent, and because it has got triple bonds, pentyne. Now summarize pentyne. We said the alkynes. We said the general formula CnH2n minus 2. The first member starts with 2 carbons. 2 carbons means CnH 2 into 2 minus 2. And that will be this will be 2 because 2 carbons, 2n minus, so H2. Because it is 2 carbons, it is eth. And because it has got triple bonds, it's ethyne. Now let's get on to see what happens with 3 carbons. 3 carbons means C3, H2N, 2 into 3 minus 2. So that would be C3, H6 minus 2, and that is 4. Now because it is 3 carbons, it is prop and triple bond, so it is propyne. Now we go ahead and see what would happen if there are 4 carbons. C4, H2 into 4 minus 2, that is C4, 8 minus 2, 6. So here you have 4 carbons, so it is but, and because it's got triple bonds, it is butyne. Now for 5 carbons, we'll have C5, H2 into 5 minus 2. So C5, 10 minus 2, and it is 8. And the name would be again, it is 5 carbon, so it is pent, and it's got triple bonds, so pentyne. So if you want to write an alkene, say with 17 carbons, what would be its formula? Cn, H2n minus 2. So C17, H2 into 17 minus 2. C17, H34 minus 2. C17 and H32.